Hi everyone, my name is Anvita Bansal and we are back with another lecture based on stacks and queues. So let's move to our problem statement. Before that, I'll just quickly check if you guys are able to see my screen. Yeah, we are live. So let's have a look at our question. So you are given an input stream A of n characters consisting of only lowercase alphabets. While reading characters from the stream, you have to tell which character has appeared only once in the stream till that point. If there are many characters that have appeared only once, you have to tell the one that has appeared in the very first. The count in the index of that character is less than the other character appearing once. I'll explain you using the example. If there is no such character, then append hash to that particular answer. Okay. So let's see one by one what does this question try to say. For example, I take double A B C. Okay. So this is our problem statement. We have A, B, C. And the answer for this that we have to return, the string that we have to return is given A hash BC. Right? That is what we have to return. Now, how do we come up with this solution? See, the question says that for each index, when I'm at this index, so far, which is the character that has appeared only once? So that is your character A only. Now when I'm at this index, that is this index, so you have to tell so far which character has appeared only once. So the count, I can see there are total two characters still here, and those characters is actually A having a count of 2. So I can say that I have not found a single character having a count of only 1, right? So I have to find that character appearing only once till ith index of my string. So since I did not get any such character, I will append hash to that position where I am trying to find. Now when I am at this index, I will be checking all from 0 till this ith index, which is the character having count of 1 and appearing before any other character having the same count of 1. So if I see I have A appearing twice, I have B appearing once. So clearly B is winner and I will update B here. Okay. Then comes this index and I am traversing on the string till this index. So I will check that A has a count of 2, B has a count of 1, C has a count of 1. Now I get two characters having the same count, that is equal to 1. But what should I append in my resultant string? The character which has appeared before the other one. So I will basically append B because it was a tie here, but the deal breaker was, or the tie breaker was, the character which was appearing before in the string. So that was B. So sorry, this is B. Okay, I already wrote B here. Till here what we were discussing, it was B. When I was at this character, which is the non-repeating I think answer should be A hash BB. Yeah, I think I wrote it wrong. So I think you got the question. This is just a mistake here, that it should be A hash BB. So this is, let's take one more example and we will see how it is working. Let's see if your test case is given a good test case. So if I check for ZZ, it is what? Z hash. The reason is that till 0th index you have only Z appearing once. Till first index you had Z appearing twice. So that means you do not have any character that is appearing only once. Let's take one more example. Check. Okay. Let's take one more example and we will see if how we have to return the answer. That's for your understanding. For example, I have a string like this, which is A, B, C, B, B, D, E, D, F. For example, this is my string. Now, how should I be returning the answer? So I should be returning the answer in this way. Till this index, I should have only A as the character appearing once. Till this index, A has occurred twice, so it should be hash, replaced with hash, because there is no character appearing only once. Till this index, I have A twice and B1. So clearly B is winner. Till this index, I have B1, C1. So clearly B is winner. Till this index, I found A twice, B twice, and C only once. So clearly C is winner. Till this index, I got only C as my character which is appearing once. So I will append C here. Till this point, I have C appearing once and D appearing once. Rest all are greater than 1. The frequency is greater than 1. So now the tie is between C and D. So which one should I return? The one which is appearing before. So that will be C. So C is your winner here. Now I'm at this index. I have C, D and E all with frequency 1. But the character which is appearing before any of these is C. So I will be appending C for here also. I have D again. Again your clear winner is C. For this character, I have F appearing once, but your clear winner is C because that is the character which has come in the very beginning. That means the place that it occupies is way before than all these characters. So these characters did not get a chance. If let's say it has been C, for example, if it was C, now your C came twice till here. So the only character appearing once is D. So this would have been replaced with D here itself. Now you found a new D here. So D has also gotten a frequency of 2. So clearly D cannot win. So which character should win? Let's check the character occurring only once. A twice, B thrice, C twice, D twice. So there is no character. So this is how this answer is going to alter. This will be hash. And for F, now the winner will be F because I am left with only F as the character having frequency 1. This has been omitted. Okay. So I hope you understood the problem statement. Let me check. Okay, Amit, I will explain you the question once again. Let me know if using this example you got the question or not. One more time, I'll explain you the question. So your question is about that you will be given a string. Okay, for example, AABC. You were given a string AABC. Fine. For each index, you have to check while you are iterating over the string, you have to return a string in such a way that the character that has occurred only once should be appended to the new string. For example, when I am at this position, 0th index, which character you find appearing only once? A is the character coming only once. Now when I come at first index, so in this string, do you find any character appearing only one time? No. So replace the index with, means append hash when you find no such character. Then you come at this index. So for this index, you are basically considering this entire string starting from 0th index till ith index. Now you have to check if there is any character occurring only once. Yes, you have found that character, append with it. If you find more than one such characters that are occurring only once, then you have to return the character which is coming before in your string, right? The very first character that is occurring one time. Now when you come at this index, now you are actually checking for the entire string if there is any character occurring once. Now we have B also coming once and C also coming once. So which character should I be appending? Actually B, because B is coming before C. So that's how we are doing. I hope this is clear to you. Fine. Now let's move to how we can solve this problem. So this problem can be solved in a lot of ways. One, brute force approach, not brute force, or the approach that might come to your mind very easily in the very beginning might be that let's create a frequency array, or let's take a hash map. Okay. For each hash map, we are checking as we are traversing over the string. I am checking if map contains that character. If it contains, I add in my map and update its frequency. Now the next time when I come, I again check that my frequency has been updated, and simultaneously I will take another array which is your count array, maybe it can be anything, and there is another string which will be storing the characters that you are trying to append. Okay, so for each time you'll check in your map that there is a character appearing only once, you append to it. Okay, so that is one way. I'm sure you must have, you can try it on your own. Coming on to trying this approach, actually we can optimize this approach and try to solve this in exactly on of time complexity. How can we do this thing? Obviously we will be using space. In the first approach also we were using space, but that will be like 26 times n, because we will be iterating over your frequency array also that you might be creating. Okay, so let's try to solve it in on of time complexity. So for that, what are we going to do is, I am going to take a queue. Have a look here. Let's take this example itself. This is a good example. We will take a queue, okay, and we will take a character array. Characters array task will be to update the frequency. Basically that will be updating the frequency each time I'm coming across any character. So that is basically I'm taking an array of size 26, that is corresponding to the number of characters I have in my alphabets, number of alphabets I have in my dictionary. So that is for A, B, C, D, that till 26. Okay, fine. This is your frequency array. Now let's start off with iterating over this string. When I'm at 0th index, okay, when you are at 0th index, you have in your frequency corresponding, so this 0 index, let me tell you, this frequency array is of type integer, right? Now I have to make this array in such a way that 0 corresponds to small a, because it has been told that all the characters of your string will be in lowercase. So if I do like this, that character minus 97, that will correspond, 97 is the ASCII value for small a. Similarly 98 is the ASCII value for small b. So if I do it in this way, that frequency, let's say this is your ARR. So ARR of this will be the, this is how I'm going to point to the indexes at which I will be trying to update the frequency. So this is your character, right? Character minus this ASCII value will give me index 0. When I found a, I am updating its frequency and I am adding it to the queue. Okay, also this is my final string. This is my final string where I am updating my answer as a. Coming on to I equal to 1, right? Now my I is pointing to this index. I found an a again. Now I will increase my frequency for sure, but now I see that my frequency is greater than 1. Whenever I check that frequency is greater than 1 for that character and my queue is also not empty, first thing that I'm going to do is remove the first character. Basically in a queue, whenever you do this remove operation, the character from the front of the queue will be removed. This is your front, okay? So front, and this is your rear. So front of the queue will be removed, and that is why when you found that the next character that I am at, I saw that I have updated its frequency. If this frequency is greater than 1, then I am removing that character from my string, from my queue. So my queue now becomes empty, right? Now your queue becomes empty. Since you do not have any character to update in your new string that you are trying to return, you will append a hash there, because that means you did not find any character whose frequency was 1. Till now others are 0 and a is 2. So there is no other character which is occurring only once till I equal to 1. Now your I is at 2. Now your I is at 2, right? So you found a b. Let's update the frequency of b. So b, this is corresponding to a, this is corresponding to b. B now becomes 1. Try to understand this thing. B now becomes 1. You add it to your queue. The queue will be of type characters and you are adding it to your queue. Now your queue has b. Fine, that's okay. Now since you found a b, you append it to your string, because the frequency of b was 1 only. So as I am adding to my queue, I'll check if my frequency of that character is 1, I will append it to my string. Now my I is at third character, which is C. So I'll update the frequency. So C will become 1 now. Since it's 1, now you see that you will also add it to your queue. As in when I find a character, I am adding it to my queue. Only when I find that my frequency is greater than 1, I remove from the queue. Else I am always adding into my queue. Now when I add it to my queue, C got there, but I have to update my string also simultaneously. So string will be updated with the character that is always present in the front of your queue. Right now the front of your queue is B. That tells you that B has been found in your string so far, and it has a frequency only then it is in the queue. Any character which is exceeding the frequency of 1 will be removed from the queue. That is what we are doing. So that will ensure, this queue is always ensuring that the character that is present in the queue, first of all, they all are with frequency 1. Now they are present in the queue in such a way that the frontmost character is the character that has occurred in the very beginning of your string. So if I want to append it to my final resultant string, I will append the character from the front of my queue. Right now my I is at 4, that is I am at this character. When I am at this character, I update my count of B from 1 to 2. Now this one becomes 2, right? This one becomes 2 now. When it becomes 2, I have to make sure that my queue front gets removed. Got it? So when I remove it from my queue, this will be removed. Now I am left, and I will be removing until I get the character with frequency 1. Till then I will keep removing. This will be a loop in your queue that will be removing the characters from the front until you get a frequency of 1 character. Now you found a C, and C's character is 1 only. So C's frequency is 1. So you will append the front of your queue C to your final answer. Now you are at this index I equal to 5. Again you found a B. Now B will become 3. I'll just write it here. Now your B has become 3, right? Okay. When your B has become 3, that means it has exceeded the frequency. Obviously, already I have, let's check what is present at the front of the queue. The front of your queue is C, which already has a frequency of 1. So I will append that character itself to my answer. Now let's move ahead. Your I is 6, you move to D. Now let's see, when I move to D, the D's frequency will become 1 now. Okay, you will append it. I think okay. Also, see, you must be wondering why did I not append B to my queue. So I just missed writing it, but every character that I'm traversing, I'm actually adding to my queue as well. So after C it was B, after C it was B, after B it was B again, then it was D. Okay, now it is D, right? I have appended D. Now you check D's frequency is 1. Fine, I have any character that I'm traversing, I am already adding it to my queue. Just that if its frequency is greater than 1, I am removing from the queue until I get a character whose frequency is 1. If its frequency is not 1, I will simply take the element, not remove, but take the element from the front of my queue and append it to my answer. Now when I'm at this ith 6th index, 0, 1, 2, 3, 4, 5, 6, 6th index, your D has been added to your queue, its frequency is 1. Now you will see what to append in your answer. So now your next answer will also be C, because it is in front with frequency 1 only. Okay, so that statement which I said that we are always adding those characters in the queue whose frequency is 1, that is not correct. We are adding all the characters in your queue. Just that when I find that a character is exceeding the frequency of 1, I am removing from the queue. Got it? Okay, now let's move to 7th index, which is this character. You found a C. Your C's frequency has increased to 2 now. So you will start removing from your queue until you get an element whose frequency is 1. You remove C. Right now, which character is present at the front of queue? It is B, and B's frequency is 3. So you remove B also, and simultaneously you can update the frequency as well. It becomes 2. C becomes now what? No, this stays same. This stays same. It will not update. Okay, next is B. Again, B's frequency is 3. So this tells you that these are the characters that have occurred more than once. So their significance has been eliminated now. They do not have any significance, because I am only looking for characters that are appearing one time only till ith index. So this B will also be removed. Now I found a D. What is D's frequency? It's 1. So I will keep it here. Now I have to append to my string. So the character in the front of the queue will be appended. If my queue was empty, I would have appended hash in place of that. Now my I is at 8th index, that is at this index. What is the frequency of D? You will append, you will add 1 to its frequency, because you have found it twice now. Now since its frequency has become 2, you check the front of your queue is what? It is D, and its frequency is 2, right? So you remove it from the front of your queue, right? This was the front element. Now your queue is empty, there is nothing left to remove. You have to append in your final answer as well. Since there are no characters, your queue is empty, you will append a hash there, right? We got a hash. Now my I is at 9th index. You check F was not already present in your F frequency. We will add, this was E, right? Now you found an F, so F frequency becomes 1 here. You add F right here. Okay, I think I missed writing C here after B, D, C. It would be C, then it was D, and then it was F. And since C was also 2, it was also removed. D was also 2, it also got removed. And now we are at F. F gets added to your queue. You add a F here, because F's frequency is 1 and it is in the front of your queue. Now that's the end of the string, and this is how we have created our final resultant string: A hash, BB, triple C, D hash F. Okay. So I hope you understood the solution. Okay, so let's see and have a look at the code. Exact things that I discussed is what I've written here. So creating a queue of type character, right? Then we have a frequency array I've named ARR of 26 length. Each index corresponding to lowercase alphabets starting from A till Z, right? 0 corresponds to A, 1 corresponds to B, and so on and so forth. String builder resultant, this is a resultant string. Now iterating over each character. Iterating over each character in your given string. For example, A, B, C. I am taking CH as the character corresponding to ith index. ARR CH minus 97 gives you the exact index corresponding to that character. Increment the count, because as and when you find a character, you are incrementing its count in the frequency array. If this frequency is exactly equal to 1, add it to your queue. Then you check while your queue is not empty and the frequency of the character that is found at the front of queue is greater than 1. You keep removing. There's a loop here. If your queue is empty, you append hashtag, otherwise hash, otherwise you just append, otherwise also you are appending to your, you append the peak, that means the front of your queue, to your final answer, and that's finally what you are returning. You convert string builder to toString and you return the answer. If you have any doubts, let me know. So how much this is a one pass solution. We are exactly traversing over each element only once, and here we are taking some time, but that will be added. Okay, that will be added. That is also conditional. Not every time we are doing this thing. That is why it will take big O of n time complexity. N is the length of your string. Okay, so that is all about this question. If you have any doubts, you can ask me. That's all, everyone. So should I give mock interviews? It depends how your preparation is. If you are good to go, that means you must have solved bare minimum questions from SD Sheet. SD Sheet is a good curated list. If you think that you have solved all around 90% of that sheet, you are ready for mock interviews. Even if not, I wouldn't say not to try for mock interviews, but that will be like you try it. If you are able to pass it, that means your skills are good at coding, or you can try for more interviews. But if you fail, you I would suggest you to first do some basics, that is at least solving these many problems that are there in your ST sheet, bare minimum. So that's all, everyone. Let me know if you guys have any more doubts. If you don't have any doubts, let's wrap it up. Okay, guys, then that was all for today. See you all in the next lecture. Bye bye. Take care.